Unfortunately, Unity's physics by default are something like this. You would expect a moving platform currently supporting you to carry you where it went, but that's not the case. However, today that's exactly what we'll be doing. So as usual, let's not waste any time and get straight to it. This will be fairly quick, but we'll create two scripts to make it work. Have one called RigidBodies and one called RigidBodies Sensor. We'll work using the onCollisionEnter functions and detecting when a rigid body has landed on a carrier and moving it along until physics detects that it's left. Unfortunately, brushing against the bottom of a moving object would trigger a collision as well, and this would result in an object carrying something by the top as though it were a magnet. That's why we'll incorporate a sensor to pair with the carrier. If that doesn't make sense now, it will later, but for now, enter RigidBodies. Since the number of objects we should carry is undetermined, we'll use a list instead of an array to hold all the rigid bodies to carry, so incorporate system collections generic, and make an empty list of rigid bodies. Now remove update and add two void functions called onCollisionEnter and onCollisionExit, both with a collision parameter. These functions will be called automatically when Unity detects a collision on the object that the script is attached to. That makes it very easy for adding and removing bodies. Inside Enter, get the rigid body component attached to the collider object. If the rigid body is not null, then we know something's touched the carrier. Copy and paste into CollisionExit like this. Now let's make public functions for adding and removing a rigid body from our list. This is so our sensor will be able to add and remove if we choose to use one. Now back in Enter, if a rigid body was detected, add it, and if it exit, remove it from the list using our add and remove functions. Now in add the rigid body to the list if it's not currently contained. In remove it only if it is contained in the list. Let's let that compile in Unity and check for any errors. It looks like we're good. So this is the platform I'll be demonstrating with. In order to make it carry rigid bodies that land on it, I'll add the RigidBodies script to it. And I'm going to place a rigid body cube on top of it. So now let's check it out. Once the cube lands on the platform, you can see that it's now been added to the list. But that in itself won't make a difference, so let's go back into our script and control how these objects are carried. Start by adding a vector 3 called lastPosition. On start, set the last position to equal the current position of the carrier. Now create the function lateUpdate, which will be called after update every frame. Inside here, we're going to move each rigid body according to the current velocity of the carrier. We get our velocity as the current position of the carrier minus its last known position, although it'd be more efficient to locate this outside of the for loop. Now move the current rigid body using transform.translate and using velocity as our movement, and the carrier as the forward reference. After moving all rigid bodies, update the last known position to the current position of the character. That way we can update our velocity for the next frame. Now watch as our platform carries the rigid body without the need to parent it. Now I'll move my character to the platform. And you can see we're carried very easily. Once we get off the platform, then we'll no longer be carried. So I'm satisfied with that. I think that's about it for the carrier script. But now let's make the sensor. As an example of why we might want a sensor, imagine our platform. Now imagine we have a rigid body that looks this good. As stated, we're using collisions to detect and control rigid bodies, so as long as they collide in the right spots, everything works great. But imagine that we don't land on the platform, but rather graze its side. That's still a collision, and rigid bodies will start to look more magnetized than anything else. This is where a sensor defines one or more areas that act as our collision detection. So only by hitting the spots we want will a rigid body be considered a tag-along object. Make a boolean in the carrier to use or not use sensors. If we don't, then standard carrier collision will be used instead. And of course I just couldn't decide on a name right there. Now enter the sensor script and create a hidden public reference to the carrier object the sensor will be a child of. Remove start and update and use onTriggerEnter and onTriggerExit with a collider parameter. Get the rigid body of the collider and attempt to add it by using the carrier if the rigid body is not null. Ensure that add and remove are both public in the carrier script. That way we can use them from the sensor. Now go into the carrier script and make a rigid body variable for the carrier itself. Define it in start, because we don't want our sensors to detect their own carrier. That would cause real problems when we go to move the child objects. Or not the child objects, but the rigid bodies attached. Now in the sensor, if the detected rigid body is not null, and if it's not our carrier, then we'll be able to add or remove it from the list. Copy and repeat for onTriggerExit, but change add to remove. Finally, go back into the carrier and set any child sensors to recognize this instance as their carrier. Always make sure any sensors for an object are children of the carrier. But of course, only do this if we're set to use sensors. Enter Unity again. And now let's use the sensors. You can see that operating without sensors works in this case, but now let's try with a sensor object. But I haven't set up a sensor, which tells me that we're still using collision here. Back in the carrier script, in onCollisionEnter and exit, make sure if we use sensors that we return before any of the other code can execute. So now let's try it again, and this time the cube shouldn't be carried with that platform. So you can see our carrier collision is ignored because it expects a sensor to do the work. The last thing to do here is just make a sensor. I've already got one here, but without the script. Once you have a sensor, add the sensor script to it and make sure that it has a collider and is trigger. The sensor is now handling the addition and removal of rigid bodies, so now only a collision from the top of the platform will allow a rigid body to be carried. Here's an example of nearly 180 rigid bodies being carried at once. So you can see this is very easy to do and very performance friendly. If you found this helpful, please give us a like and subscribe for more videos. Thank you and goodbye.